Hello everyone. In this video, we will discuss tools chain. It means what are different tools, utilities involved when any source program getting compiled up to execution. We are going to learn GCC tools chain. GCC stands for GNU Compiler Collection, and we also seen what is GNU. GNU is GNU not Unix. See, the different tools present in a GCC are as shown here: preprocessor, assembler, compiler and linker. Many more tools are there, but what we are requiring in a primary steps that I am going to discuss with you. There are disassembler, there are decompiler, there are debugger, there are interpreter, etc., etc. Depending upon what different software you are using, the number of tools are going to vary. Well, let's start with the GNU compiler collection. For that matter, I require a simple C program. In a previous session, we have seen hello by libc. Let me open that simple file. Okay, see, vim hello by lib.c. In this C program, just I have used only a printf library function. This printf is referred from stdio.h header file. Okay, let me save the program. The usual practice what we do follow is gcc -o hello by lib and the program name hello by lib.c. Here hello by lib.c is a source program and the output file will be hello by lib. Enter. So it's compiled and its executable is also getting created. So how to execute? We know hello by lib. Enter. And here we got the output. So whatever task involved in this operation that we are going to disaggregate. We are going to understand the internal steps followed when any GCC file creates an executable file. Here the C is the source program, -o by which we have created the output file, and internally GCC used different tools to create this executable. So let's discuss all these tools one by one. Preprocessor. Preprocessor is CPP. Here CPP stands for C preprocessor. To this C preprocessor, let me give our normal C program as an input, and I want its output as hello by lib.pp. Here extension doesn't matter, it's just for understanding. PP stands for preprocessor. So let us execute the command and we got the output as hello by lib.pp. Okay, before that let me open our C program. Look, this is a preprocessor instruction, and as I mentioned previously, printf function I referred from stdio.h header file. What happens here? What does preprocessor do? Printf function is actually whatever the header file is there, stdio.h, the content of header file will be included in our hello by lib.c program. Let us see the outcome of this CPP command. Look, many lines will be included here. Let me go to the end of the file by pressing Shift G. Now you might be finding the familiar code over here. The same code what we have written in a .c file. What about previous content or previous number of lines? These are the statements or the lines from stdio.h header file. Simply speaking, the content of stdio.h header file will be copied into our program before compilation. That's why it is called as preprocessor. Whatever the instruction started with hash directive, it is nothing but preprocessor. Before compilation, some steps are to be taken whenever such hash directives are there. So hash include means including or inserting corresponding header file. This is what they done, and we actually do not understand the steps in this way occurred while we use only GCC. Let's move to the next command, that is identifying the assembler's output. Before compilation, the assembly file as an intermediate file is also getting created. The command is gcc hyphen capital S. This is one extra switch, one extra information we are providing to the gcc command. The outcome of this file hello by lib.a, and the input file is hello by lib.c. Look, to the GCC I am providing input file as hello by lib.c. I want the output file name as hello by lib.a, which is given by -o option, and one extra option I am providing here hyphen capital S, which gives me the assembly file. Whatever we are writing in a C program, its assembly program is now getting converted. Let me execute it. Let us see the content of the file hello by lib.a. Again, here extension doesn't matter. For our understanding, I have given extension as A for assembly file. Enter. Look, these are the contents of the assembly file. Whatever the underlying hardware architecture is there, based on that, the commands or the mnemonics are created and assembly file is generated. Well, the second preprocessor we finished. The second tool, assembler, also we discuss. Now we are going to see in detail the compiler. gcc-c. For only compilation, we have to provide -c option to the GCC tool. In previous command, we have given -s option to the GCC tool to generate assembly output. Here, we are going to provide -c option to the GCC tool to generate the compilation outcome, and output of compiler is an object file. -o hello.o, and the input file name is, sorry, not only hello, it's hello by lib.o, hello by lib.c. Okay, so let's do it. Ta-da! We got the output successfully without error. If any syntactical error present, it is displayed on the terminal. You people are knowing this. Hello by lib.o is a binary file, but it is not an executable file. It is an intermediate result generated by the compiler. Let's see its content. It's a binary file. Definitely we are unable to read the content. Look, it's the outcome of compiler. Well, now the next utility, linker. Linker is LD command. So LD, name of the output file, hello by lib, this is my executable file. Then we have to provide switch called as LC, then dynamic linker, and the name of linker program, it's lib64/ld- I am just pressing tab Linux -x86 64.so.2. Here my operating system is 64-bit. That's why the name of or the path of linker is like this. I need to specify as input to the linker, that is outcome of the compiler. Look, compiler takes .c header source program, it's create object file, and this object file I am providing as an input to the ld command, that is linker command. Let's execute the command. Oh, there is a warning. Cannot find entry symbol underscore start, which is our entry point function. In a C program, the entry point function is main, and this linker is not able to find it out. It is actually finding it with the help of underscore start, but in our source program we have defined it by using main function. So let us put or let us mention the entry point function and give as an input to the ld command. For that matter, we have to specify the name of entry point function by using switch -e. E stands for entry point function. Just mention the name of function as a main. If you implement another function rather than main function, so for compiling such programs and executing such program successfully, instead of main function, you may write that another function name here. So you can write C program without main function. Enter. We have hello by lib as an executable file. What is it? An executable file. So run it, hello by lib, and enter. Oh, welcome to Linux system programming. We got the output, but there is an error. It is a segmentation fault and core dump occur. What do you mean by core dump? Whenever abnormal termination of process or program occurs, the core image file is created. So one can open this file, one can analyze it, and one can find it out the reason of abrupt termination of the program. And what does segmentation fault means? Usually speaking, this particular exception or error occurs when you access such a memory area which is not assigned to you. Okay, that's why segmentation fault occurs. So we can replace or we can overcome this particular error. Let us go to our program hello by lib.c and let's do some, sorry, I have opened some another program. I should write hello by lib.c. Enter. Look, instead of return statement, if we use another system call exit in bracket 0, this exit performs all cleanup tasks, whereas return does not. That's why segmentation fault has occurred. If I am using exit system call, I need to include corresponding header file, it's stdlib.h. Let us save the program. Here exit perform all the tasks, and let me compile it now directly. -o, or shall we execute one by one? Okay. Let us compile first once again and let us run it by providing -e. Enter. Let us execute the command. Command will be name of the executable /hello by lib, and we got the successful outcome. There is no segmentation fault error, and we just have the outcome of printf function. Well, these are the commands or the utilities involved in a GCC. So only GCC is a tool, it's not a compiler. So GCC comprises of different softwares, different tools, which we have discussed right now, like assembler. Name of the assembler is AS. Name of the compiler is CC and name of the compile linker is LD.